Okay. First, let's go ahead and go over the general inverse functions. And I'm sure you may have forgotten, but just in case. And if you haven't, let's go over it just in case. So we said back in college algebra that if you had an inverse of its original function and everything cancels, leaving you with an x, and that works for all x in the domain of f, the one that's inside. So this needs to be true for all x in the domain of the inside function. Okay, if that's the case, then f and f inverse are truly inverse of each other. Of course, I'm using this notation, so I'm telling you it is, but anyway, this needs to happen for them to be inverses. If you had two different functions, but it has to happen both ways. So this needs to cancel, leaving you with just the argument. But for this needs to hold true for all x of in the domain of the inside f inverse. So for all x in the domain of f inverse. Okay, so I'm going to apply this idea to all the sine, cosine, tangent, etc. I'm going to write down the location as to when they cancel, when they where it's defined, because you don't need to memorize all that. Just make sure you have that handy somewhere. So let me give you the definitions. This is the general idea. Now let's get to the inverse sine. So inverse sine function inverse sine function. Let's see, put right here, I guess. So y is equal to sine inverse of x if and only if x is equal to sine y. Okay, so basically you can rewrite this in both directions. So you can, if you have this guy, it can be transformed into this can be changed into this. Okay. The domain for the inverse sine has to be within -1 and 1. And range must be between -pi/2 to pi/2. One moment. So I'm going to give you all three: sine, cosine, tangent. Now inverse cosine. We've written as y equal to cosine inverse of x. I'm going to use IFF because in math we say if only if is represented by this. So same thing as up here, just IFF. X is equal to cosine y. Domain is similar, -1 to 1. Range will be 0 to pi. That's what I define on the top half of the circle. I don't know if you guys remember, but you have to have in order for there to be an inverse, the function needs to be 1-to-1. Which we'll talk about in a little bit. That's where they're restricted the way they are, because the original functions, they go on forever, right? The original sine, cosine, tangent. But notice here, they're kind of cut off. So they purposely cut them off because otherwise you cannot define the inverse. But anyway, we'll talk. You've already gone over that in college algebra, so I'm not going to test you on that. But I do expect you to be able to use the inverse functions. So here's a tangent. Y is equal to tan inverse of x if and only if x is equal to tan y. If you prefer to use arctan instead of tan inverse, that's fine with me. I don't care. It's just a different symbol, that's all. The domain is everywhere. Yeah, domain is everywhere. Range is within negative pi or 2 to pi or 2, but not including the endpoints. So this one doesn't include the others did. Notice how the other ones were equal to, right? Less than or equal to. Here we are not. Okay, so let me give you all the properties for sine, cosine, tangent, and we'll start some examples and then we'll move on. Okay. Yeah, you can put them down here. So these next formulas I just wrote down because it's a little easier to just remember this instead of trying to figure out, instead of memorizing where all the domain and ranges are, because that'll determine if they're going to cancel or not. Just use these shortcuts here, these formulas, and you should be okay. So if you have f inverse of f, in other words, sine inverse of sine, that will cancel, right? Now check it out. These cancel. It all depends on what's inside. So the inside, we said the domain. Okay, sine inverse. Yeah, so here we have to look at the range. So this will only cancel if this argument, this angle is between negative pi over 2 to pi over 2. Okay. If you have something different, you either have to adjust or there will be no solution, right? So if sine inverse is on the outside, you look at this part. You need an angle within here. Okay. Now, if you have it the other way, f of f inverse, which means it's going to be sine of sine inverse, they will cancel if your x is between -1 and 1. Okay, now let's do cosine. So these cancel if x is within 0 to pi. Cosine of cosine inverse will cancel if your x is within -1 to 1. All right, now let's do the tangent. F inverse of F will be equal to cosine inverse of cosine if, oh, I'm sorry, tangent, shoot. Tan inverse of tan will cancel if x is within negative pi over 2, not equal to pi over 2. And the other way around will cancel if, actually will cancel all the time. You don't have to worry about it for any x. Okay. That's all the formulas we're going to need for this section. So open your unit circle if you got it. Might be helpful. And let me go ahead and open the homework too. 1 second. So that is 6.6. Oh, there it is. Getting it. You guys see the homework? Okay. So the beginning, it just talks about how there's different notation. You could use arcsine, which is easier to write because the -1 can be confusing, but it doesn't matter. The book likes to use a -1, so that's what I used. In my opinion, I think the book used this one because it's less print, so they can have more space on their pages, but whatever. Arcsine is longer to write, but easier for us to understand. So they'll ask you the domain and range that I just gave you for each one. So those are just definitions. Then they'll start asking questions. So arcsine of 0, in other words, sine inverse of 0, same thing. So look at your circle. Essentially what it's asking, you guys see the circle? It's asking which angle gives you a y value of 0, right? Sine inverse of 0 means find the angle that gives you a y 0. It looks like it's going to be right here, right? You also have to remember where is sine inverse defined, and I told you in the definition, the first couple of lines we said the angles, the range is going to be within negative pi over 2 to pi over 2. So negative pi over 2 is down here. So it's actually only this half of the circle. So it goes counterclockwise to pi over 2, and then negative clockwise to negative pi over 2. Okay, so even though negative pi over 2 is the same as 3 pi over 2, it's not 3 pi over 2, it's negative pi over 2. Okay, it's only on this half of the circle. So if you're only looking over here for sine inverse, the only solution where you have a y value of 0 is going to be 0, right? So the angle 0 gives you a sine value of 0. So what do inverses do, right? They take they do the opposite of what the normal function does, right? The original function says, give me an input and give you an output. Inverse says, I'll take your output and give you back your input. It undoes whatever you did. Okay, so for example, a basic inverse would be x squared and square root, right? They undo each other. So if I square 4, I can square root 4 and get back to 2. So those would be an example of inverse functions that undo the operations, right? So if I plug in an angle, you will get, if I plug in, let's say, 30 degrees into sine, I get 1/2, right? That's what the unit circle tells us. It's the y value for sine. So sine 30 is 1/2. So inverse sine of 1/2 would tell you that happens at 30 degrees. Does that make sense? You see how it does the opposite. Sine of 0 is 0. Sine inverse of 0 tells you that happens at 0 degrees. Okay, so sine inverse of square root 2 over 2 would be 45. Okay, so that's how they did this here. This one wasn't all that interesting because it was the same. But this one's telling, okay, where's cosine 0? Like which angle has an x value of 0? So number 6 is asking. Like, okay, well, at pi over 2, x is 0, right? So the answer is pi over 2. Do you see how they work? The inverse. You see how it's the opposite. So the first few questions, I mean, you could use your calculator, but since these are really simple angles, you can just look at your circle and figure out, okay, well, what angle gives me the y value, because that's sine, which angle gives me an x value of 0, because that's cosine. Then you just answer the question. Any questions about that? Okay. Tangent's a little harder because it's technically y over x, right? So that would mean you would need the y value to be at 0 to get a 0. If you're looking at number 7 there. So tangent means y over x. So 0 over 1 is the only one that'll give me a 0, because this one would be 1 over 0, which is undefined. And they also tell you that tangent inverse is not defined there. So, excuse me. So it's going to be 0 degrees. So just quick recap. Sine is defined on the right half of the circle, and so is tangent, except tangent does not hit the endpoints. Cosine is defined up top of the circle. So your calculator is only going to spit out values up here. Same with sine, it'll only spit out values this positive section or negative angles. All right. Any questions so far on those problems? So let's write that down on paper really quick. So there's a couple of examples, I guess. Example 1. Let me fix that blurriness 1 second. Okay. So arc cosine of 0, which is the same as cosine inverse of 0. If we use the definition, right, we said earlier on paper, we said cosine of 0 can be rewritten as cosine of some angle equal to 0. Excuse me. So anytime, so what this is saying, right, that there exists some angle that will make cosine 0. So you can either write it this way or say, okay, well, what is the theta that makes it 0? Okay. Now we said earlier that's going to be pi over 2. So you can always change it into this form if this makes more sense. You use your calculator, it doesn't matter. But the answer is going to be, I'll write it down here. Theta is going to be pi over 2. So the question is asking is, what angle makes cosine equal to equal to 0? That's essentially what this notation is saying right here. Arc cosine 0. Find the angle that makes cosine 0. That's pi over 2. You also have to remember that arc cosine is only defined, or cosine inverse, only defined on the top half of the circle. Okay. Sine inverse of 1, that's the same thing as asking, okay, sine theta, you know what, I'll write this on the next line. Let's write the instructions here. I mean, it's implied they're not actually going to say this part, but just so we know, find the theta, the angle that makes sine equal to 1. So sine inverse of 1 means, by definition, that there exists some angle that makes this equal to 1. So you can change it via definition back and forth. Okay. That's supposed to be a double implication arrow, but I can't draw. It's the only if and only if logical symbol, basically, if you've taken logic. Or studied it. Okay. Anyway, any questions on what inverses are and how they work, and how to find angles? Oh, let's move on then. Now we can use the inverse function to help us solve for angles. That's the only reason we bring this up. I forgot to answer the question here. Theta is equal to pi over 2. Okay. So all these are very similar, just a little bit harder. So I'll leave these to you. Let's get to something different. So number 16, they want us to solve for theta. So the only way we can do that is to use one of the trig functions in terms of this triangle, and then solve for the angle using inverse functions. Okay. So one is to solve for theta. One second. And they give us this triangle. So currently we have what? An unknown under 3. Let me switch back to the paper. So they want us to write theta in general terms. They don't actually want us to solve like for a number, because we have an unknown. We have 2 unknowns, so we can't do much. So we need to pick a trig function. We have an opposite and an adjacent side. So we should pick the function that has both of those, which is either tangent or cotangent, either one. So tangent of theta is equal to the opposite over the adjacent. So the whole reason we brought up inverses was so we can do this, as we do tan inverse of both sides. To cancel this, and we get theta equal to tangent inverse of x over 3. So theta is in terms of the inverse function. So this is the answer they want. So you define the function and then solve for theta. If these are all numbers, then you would have some weird number here. Okay, some angle in degrees or radians. Does that make sense? Okay. Okay. So you have a few examples that are just like that. You give you a triangle, solve for theta in terms of whatever they're talking about in your homework. See, this one has the adjacent and hypotenuse, so you should probably use cosine, because cosine is equal to adjacent over hypotenuse. And this is the exact same thing, they're just a little uglier, but it doesn't really change anything. So I'll leave those to you. 19, 20, 21, those all depend on those definitions I gave you on page 1. Remember I said these cancel depending where the x value is, or the theta. So this is impossible because this is outside the range of values I gave you, or the domain. Okay. If you look at first page, the notes, I numbered them. If cosine is outside, cosine inverse, right? They're using arc cosine, but it's the same thing. Number 4, it says that x must be between -1 and 1. Square root 2 is bigger than -1, or smaller, I should say, more negative. So it would be impossible. This one's fine because it fits that range I gave you. So you just put 37, they cancel out. So you're just checking, do they cancel and do I get that number? That's how you're going to be doing. Okay. They cancel, whatever. Oh, this is a reciprocal. So they might try to mess with you a little bit, but they're not difficult. Let's take a short break. I need to get some water. It's like 10 minutes. Be back at 12:20. Okay. Be right back. So here, there's no actual numbers. Just write an algebraic expression. Oops. So write an algebraic expression that is equivalent to the given expression. Sine of arctan. Okay. So what I want you to do is treat this as some angle, the inside part. Again, this is the same as saying, don't forget, arctan x means tangent inverse x. Same thing. Okay. So to make this easier, let theta equal to arc tan x. And then use the definition to change that to say that this means that there exists some angle of tangent that will give me x. So this is the definition right here. The once I let theta be the inside, apply the definition, and then build your triangle. Essentially what this is asking is, tell me what sine is given this information about arctan. That's what they want you to do. Okay. So if theta is right there, tangent theta is equal to x, that means that we have the adjacent or the opposite and adjacent equal to x over 1. Okay. And if you solve for the hypotenuse, I'm going to skip the Pythagorean theorem if that's okay, to get this one. Is that okay? Do you see how we got the hypotenuse? Don't forget that a squared plus b squared equals c squared. So that means that c is equal to the square root of a squared plus b squared. In our case, we have x squared plus 1 squared, which is the hypotenuse, right? This part I didn't show. So what is sine? Let's use a triangle. Yeah, opposite over hypotenuse. So that's it. That's what they wanted. That makes sense. So just use this setup right here, and then you can build the triangle and answer for a general x. Now you'll do the same thing for this one. Notice how they got this here. This guy will be the same. So you'll let the inside be equal to theta, change it into sine of theta equals 3x, and then build your triangle. And then solve for cosine. Okay. Any questions about number 4? Okay. So let me know if something's weird or doesn't make sense. Okay. Let's go and start the review. Unless you guys have any questions about this section. These ideas make sense? 6.6. Technically, they should be rationalized, Michaela. The homework didn't, so I left it alone. Technically, you should. It's more proper to do this. But they had left it alone. They left it like this, so it's cool. All right. Let me open the review, make sure it works. If you started the review, you should be pretty good for the exam. I don't think I've put a due date on it yet, but excuse me. So I'm not going to, the review won't be worth, it's not for a grade. It's just for practice to prepare you for the exam 1. Okay, that's it. That is it. So here's a review. It starts out with a few partial fraction questions. You should have a couple as well in your exam. Then they have the degrees, seconds, and minutes, minute seconds, which we did, converting an angle, etc. It's up until the last section, not this section. I think this is 6.6, right? Yeah, it's up to 6.5. So the graphing questions at the end, I just want you to use your graphing calculator or a grapher or some sort. I'm not going to require any work for any of the graphing problems. Okay. So questions like 16 through 20, no work required. You'll have similar questions on your exam. You might not have as many, but similar. Okay, so let's get started. That's your question there. Yeah, you can have no examples on the exam. So when you start taking the exam, just show your formula sheet. Front and back is fine. Any kind of formula definition or a basic note to yourself or a calculator step, that's fine. But no written out examples. You'll turn that in with your scan of your exam. Okay, so I guess we should just talk about it now. When you finish your exam, you have about 20 minutes to upload your work. Otherwise, you won't get any credit. I want to see detailed steps for all your problems. And the more steps, the more credit I can give you if the question is wrong. I don't really care what option you choose on the multiple choice. I'm looking at your work and your process. Right? If you if you leave the test blank, I'm just gonna look at your work anyway. I don't really care what option you choose. Okay. I also don't care if you choose all the right answers and give me no work. I mean, I'm probably gonna fail you if you do that. So I need to see your actual steps. And again, I'm gonna give a ton of partial credit. So even if you mess up at the end, but yet most of the work is good, I'll probably give it to you anyway. Okay. What matters is the process, not the answer. I already know the answer. Don't really care about that. Just show me, you know, how this works, right? Step by step. As far as how many steps, it's really the more the better, but certain basic steps can be skipped, of course. Just don't skip too many. Just be careful. That makes sense? Okay. All right, exam 1 review. Let's get started. All right. The partial fractions take forever, so I'm gonna do at least 1 or 2 of them. I'll do number 1 and number 3, I guess. I'll leave number 2 to you. All right, so here we go. Question 1, 2x minus 5 over x squared minus 5x minus 6. So first thing we got to do is factor the denominator, right? Once you have factored that, it's going to be minus 6 plus 1. You guys agree with the factoring? So which case is this? Do you remember? Well, these are both linear factors, correct? They are distinct. So the setup is going to be A over the first one plus B over the second one. Yeah, it's going to be case 1 because they're just linear and they're different. So we multiply both sides by the LCD. That's step 1. Well, first is the setup, I guess. Number 2, we said cancel all fractions. By multiplying both sides by the LCD. Okay, so here we go. Every single fraction by the LCD. All right, I ran out of space there. So of course, the left-hand side will always cancel everything. And it's just going to happen every time because that's the way these work. Sorry. So that's completely canceled. One of these are canceled. And the plus ones are canceled. Okay. That might be a mistake, Kayla. Let me see. You said -6. Yeah, that's right. It's supposed to be a 6. Dang it. Change all 5s to 6s in the denominator, please. I'm glad you caught it right here, though. Wouldn't have gone any further, would have messed the whole thing up. Waste of time. Hate when that happens. It's happened to me before in like 2 pages into one example, and then someone points out line 1 was messed up. It's like, damn it. You just wrote down 2 pages. Okay. So right here, make sure everything's good. Yeah, all right. So at this point, you could use the Heaviside method because this is an easier type. So you don't have to do the system if you don't want to. You could just say, you know what? I'm gonna use the other one because this is a perfect example for Heaviside method. So plug in -1 for every x. Oops. Okay. So obviously this will go to 0. -2 times -1 is -2 minus 5. That is a -7. B -1 minus 6. That's a -7 times B. So b is equal to 1. Okay. Do the same thing for x minus 6. Let x equal 6. So we're going to get 2 times 6 minus 5 equal to a times 6 plus 1 plus b times 6 minus 6. That goes to 0. So that'll be 12 minus 5. That'll be 7. 8 times that is 7a. So it looks like a is also 1. Double check though, because that makes me paranoid. 6, 12, 7. Yeah. Yeah, cool. So that means that A and B are both 1. So our final answer will be equal to 1 over x minus 6 plus 1 over x plus 1. So you see how sometimes Heaviside's better, right? Not always. So be careful when you decide to use it. Yes, I know some people don't like to have multiple tools. So if you want to use the other one all the time, that's fine. Because we could have said right here, right? Distribute all this nonsense. We would have had 2x minus 5 equal to ax plus a plus b x minus 6b. Right? Create your system. That'll be a plus b equal to 2 for the x terms, and a minus 6b equal to negative 5. So create your matrix. That'd be 1, 1, 2, 1, negative 6, negative 5. Then you would have solved it whatever way you wanted to. You would have got to here. Double check everything. Yeah. So this is the longer method, but always works. This was the Heaviside that we chose to use in this question because it was easier. Okay. Anyway. This is called equate the coefficients. And this was the Heaviside method. Some guy's last name, I think, Heaviside. Doesn't matter which one you use, just use it correctly, right? Any questions on number 1? Beginning, middle, or the end, doesn't matter. Sorry, I had a student emailing me. Let me see. I think the test will be open until Monday. Usually I leave it open until Sunday night, but I'm gonna leave it open until Monday morning. Okay. So Monday around 11:30 or whatever, I'm assuming you're done with exam 1. Okay. So you have this whole week to take it. The latest would be middle of the night Sunday or early morning Monday. As far as how much time, probably 2 hours or so. Something like that. I need to check though, but at least 2 hours, maybe more. All right, so you guys cool on the first one. Let's do another one, those types. Okay. So first thing we got to do for number 3, to know the partial fractions, is apply we got to factor the denominator by using the difference of cubes. Then we did one of those in the homework for somebody, or at least we set it up. So x cubed minus 1 is the same as x cubed minus 1 cubed. Okay. So apply your formula. The formula you're going to need, I think I wrote it down last time. And when you have 2 cubes being subtracted, it's going to be a minus b times a squared plus ab plus b squared. So here we have our 2 cubes, something cubed minus something cubed, my a and my b. Okay, so then just go ahead and plug them in. We're going to have a, which is x, minus b times x squared plus ab, so it'd be 1 times x plus b squared. So there's a factorization, applying the formula, difference of cubes. So at that point, we just got to factor or use our cases from that page, our rules. So which case is this? Like, because this doesn't factor anymore. And this is not linear, right? So it's got to be either, I think it's 3 or 4, one of those. Let's check. I forgot. Yeah, the bx plus c stuff, for sure. Case 3. It's almost exactly like the example, almost. Example in case 3. All right. So that means we're going to have over the linear factor, just an a, plus bx plus c over this guy. The non-reducible quadratic. I got to use bx plus c. Now, I don't think Heaviside is going to be good for this one because I see a lot of weirdness. And we have a bx and a c. I'm like, probably going to go with the equate the coefficients. Because the last one was very simple, right? We had just two two unknowns. So when it looks very simple, that's a good hint that maybe the other one's better. But you can always use the longer method every single time if you want. So this is the setup. Step one. What else? So I'm not going to write the left-hand side. We know it cancels every time, right? Every single time I'm just going to be left with the numerator. So I'm going to go ahead and multiply this right-hand side. Let's pretend I did the left side already. Okay, so when you multiply it, the x minus 1's cancel, and the quadratic should cancel here. Any questions on that algebra? So do you see why we don't want to use Heaviside? I'm like, oops, forgot this over here. I don't see an easy x to choose. If x is 1, I'll get rid of this, right? And I can solve for a. But I don't see how you can isolate b and c. Like I can let x be 0 and plug in the x that I found. So I could kind of power through it, but it does not seem to be any easier than the other method. It seems to be about equal or worse. So I might as well just stick to the system. Okay. If it doesn't feel like a shortcut, I don't know why I'm going to do it. So distribute the A. Okay, so this is step 2 right here. Yeah. So I distributed this right here. Distribute the A. And here we go. So now collect all the quadratic parts, all the linear parts, all the constants, and then create your system. So we have 2 quadratics, right? Three linear terms. 2 constant terms. Okay, so there's all of them together. All I did was organize. I didn't do any math from here to here. Just rearrange the terms. So the quadratic pieces will be equal to 0 because there is no quadratic piece, right? The linear pieces is equal to 13. The constants is equal to 2. You guys agree with this setup so far? Any questions on the algebra or the equating the coefficient step? Okay, let me know. Let me know if it's confusing. So just change it into a matrix. ABC, constants. And solve this. So once you solve that, you should get so when a matrix is solved, it's always going to be this on the left hand side. 1 0 0 0 1 0 0 0 1. So one's along the main diagonal, zeros everywhere else. That means your matrix is reduced as far as it can go. And then whatever's on the right hand side will be your solutions. Okay, so if you solve it with your calculator or a solver or by hand, you should get to here. Okay, so that means that A is 5, B is -5, C is 3. Let me just plug them in, and that's it. So the final answer this will equal 5 over x minus 1 plus -5x plus 3 over x squared plus x plus 1. So I'm not going to require any work when it comes to solving for ABC, but I will require work everywhere else. Okay. Any questions on number 3? I'll leave number 2 and number 4 to you. Okay. Number 5, we did one of these, I think, the other day. 1 second. Yeah. So without doing any work, can you see which 2 answers don't make sense? number 5. We can go ahead and do number 5. It's fine. But we're going from degrees, minutes, seconds to just degrees. Right? And we said in the homework example, these are just 3 pieces being added together, right? You have 15 degrees plus 59 minutes plus 15 seconds. So how the heck would that 15 turn into a 16 if these are smaller fractions? Do you see what I mean? There's no way it could be A or B. This is not going to happen. There's got to be C or D. But let's go ahead and do the work. So we said that 59 minutes would be the same as 59 over 60 degrees, right? Okay. So let's go ahead and write that down. Example 5, or problem 5. I'm just going to shorten the question. Convert to degrees. Round to 2 decimal places. "15 degrees, 59 minutes, 15 seconds." All right. So we said in the example, in the notes, that this is the same thing, right? That's what we said. We then said that, believe we said, I don't have the notes in front of me, but 1 minute was the same as 1 over 60 degrees, or 1 over 60. I believe 1 second would be 1 over 3,600, right? That's what we said. That sounds familiar. So just change it and add them up. That'd be 59. I'm going to skip a step here. Over 60 plus 15 over 3,600. Add those together, and you'll have your answer of 15.9 something. Let me get my calculator. Got it. So it looks like rounding to 2 decimals would be at 15.99. So D, right? 15. I showed less steps than we did on the homework example because I'm hoping and assuming you worked on a few of these already. But if you have some questions, let me know. Now is the time. Does it make sense? Okay. You guys are good? Number 6 is super easy. Let's just do real quick. Convert to from degrees to radians. So if they give you 105 degrees, you got to multiply 105 by the conversion factor. So I want degrees on the bottom to cancel degrees, right? So this becomes 105 pi over 180, reduce the fraction, 105 7/12 pi. So A looks like. Anyway, nothing crazy there, right? Number 7 is going the other direction. Any questions? Number 6. Okay, so if I want to get his degrees, you want to cancel the pi. So multiply by 180 degrees over pi. Yeah, that's fine. So the pi's will cancel. So I'm left with 10 times 180 degrees over 7. So that is 1800 degrees over 7. Does 7 go into 1800? If you look at the question, they have decimals. So let's go ahead and round it to 2 decimal places. All right. So don't miss those questions. They're pretty straightforward, right? Just convert. That's it. Any questions on 5, 6, or 7? Okay. Number 8. Number 8 says an object is traveling around a circle with a radius of 10 centimeters. Okay. If in 20 seconds a central angle of 1/3 radian is swept out, what is the linear speed of the object? Okay, well, let's write down everything they said. Radius of 10 centimeters. Is number 8. I'm going to go ahead and share the screen and then we'll write it. I'm going to write it down. It's number 8 right here. Okay. So I'm going to write down the radius. 10 centimeters. Time is 20 seconds. Theta is equal to 1/3 radians. So no degree symbol. What is the linear speed? You guys remember what linear speed is? Right, there was a formula that said it was what is it? It's a speed around the circle, right? Remember we said this the speed at the edge of the buzz saw or the wind turbine, whatever, right? The very tip. Or along the arc of the circle. So I believe it was, I forget the notation. Do we use V? We use V. It was S over time for linear speed. So we got to find S. S is equal to R times theta over time. So that would be 10 centimeters times 1/3 radians over 20 seconds. What would that be? 1/6. 1/6 centimeters per second. In decimal, what is 1/6? I don't know what they wanted, but we'll check in a second. .67 centimeters per second. Yeah. Centimeters per second. Any questions on problem 8? Does it make sense? No, we're just using the formula and plugging in whatever they give us. Just make sure that it is in radians. If theta is in degrees, you're gonna have to change it first. Okay. Otherwise it'll be wrong. All right, let's go to the next one then. You guys cool? So far, is the test field doable? A little bit. Should be very similar. So if you practice the review, you'll be good. Just don't fall behind on the homework because there's a ton of it. Okay, number 9. Let's see here. Okay. Turning the page, is that cool? Let me know if you haven't finished it. Number 9 says, two sides are given of a right triangle. Find the indicated trig function of the given angle. Okay. Give exact answers with rational denominators. So basically, they want us to build a triangle and find secant. It's a right triangle. All right. Okay. Find secant B when A is equal to 2 and B is equal to 5. So that's all I'm going to write. There's a bunch of other information, but that just helps you draw the triangle. And I'll switch over in just a second. It says the right angle is C. So I'm going to put B on the lower left and A up top. Yeah. So little a will be opposite to big A. Little b will be opposite to big B. There we go. Let me switch back. So they said C is the right angle. Capital A and capital B doesn't really matter where you put them. What matters is where you put lowercase a and lowercase b. Okay, so they have to be opposite to the capital letters. I'm sorry, someone's blowing up my phone. Turn this off. Okay. Does that make sense how we set it up? Is that clear? That's how we're going to be setting them up when we leave the whole right triangle stuff. So what is secant defined as? Right, we said secant is the reciprocal of cosine, right? So if we flip cosine over, that'll be secant. What is cosine? All right, don't forget, you need to know these or have them handy. Yeah, so just flip that over and we got secant, right? Okay. We do not have hypotenuse, do we? So we got to find it. So a squared plus b squared equals c squared. So that means that c is equal to the square root of all this garbage, which means that it is equal to the square root of 2 squared plus 5 squared, which is 29, right? You guys agree with the hypotenuse? Okay, so just plug it in and we're good. But notice how it has to be adjacent to B, right? If I would have said secant of A, adjacent would be over here. See what I'm saying? It depends on what angle we're talking about. Adjacent is not always the bottom side. Adjacent is literally meaning next to, right, the angle we're talking about. So like if I would have said, what is sine of A? You would say opposite of A, 2, Hypotenuse doesn't change though. Do you see what I'm saying? I mean, they didn't ask this. I'm just making a point. Don't forget. Just because I draw the same every single time does not mean we just look at a specific spot. All right. Any question on number 9? Pretty sure that's what they got. Let's check. Oh, they rationalize. Cool. Check that out. Multiply the top and bottom by square root 29, and you should get 2 root 29 over 29. So A. Any questions on problem 9? Okay. 10. 10 is not too bad. Let's go ahead and do it, I guess. Find sine theta. Shorten this up, given that tangent of theta is equal to 3. Okay. Okay. So find sine theta given that tangent is theta is equal to 3. Tangent is equal to opposite over adjacent. If I choose to put theta here, opposite is 3. 3 can always be written over 1. So 1. Okay, this is the same as, right? I need the hypotenuse for sine. So same deal. Solve for I skip the Pythagorean theorem step for the most part. Once you have solved the triangle, sine is equal to the opposite side over the hypotenuse. If we rationalize, that'll be multiply by root 10 over root 10, which gets us to here. Any questions on number 10? It's supposed to be straightforward, but if I went too fast or if you missed something, let me know. This okay? All right. Number 11 is really just use a calculator or your unit circle. I'm going to skip that guy. 12 is a word problem. I think we should do that one. Looks like it could be hard. I don't know. Yeah, let's go ahead and do that. By the way, I did upload Thursday's video, right? Can't remember. I think I sent it. Yeah, I'm pretty sure I did. Okay. I'll copy paste this into the chat. Here. Are you guys cool on this page? Okay. All right, so a radio transmission tower is 230 feet tall. How long should a guy wire be if it is attached 10 feet from the top and is to make an angle of 33 degrees with the ground? Okay. All right, well, let's draw this out, right? It's number 12. So I'm hearing that there's some tower over here. That's 200 feet tall, 230 feet tall, right? That's what I'm reading. Do you guys know what a guy wire is? So basically just a wire that kind of stabilizes the tower. You usually see them connected or holding them down, kind of like almost like an anchor. I'll give you a picture actually. Show you a quick picture. Hopefully nothing weird pops up, right? It's just a little too complicated. Where's an easy example? These right here. See those wires that come down? That's a guy wire just attached to it. Basically a hypotenuse, right? That's all that is. So we're actually looking for a hypotenuse. It says, so we have some tower, that the guy wire is attached 10 feet from the top. So not at the very top, but 10 feet down. So just like this picture, right? It's not at the tip. Okay. That's what a guy wire is. So I'm picturing the wires right here somewhere. It comes down all the way to the ground. And it says that it makes an angle with the ground of 33 degrees. And this is 10 feet from the top. How big is this side of the triangle? How tall is it? Yeah, it's gonna be 220, right here. So we don't need the 230 at all. What do they want to know? Right, they said, how long should the guy wire be? So they want to know the hypotenuse. So we should use sine or cosine, doesn't matter. Anything that has hypotenuse and an opposite side. Sine wouldn't work, actually. I'm sorry, cosine wouldn't work because adjacent's gone. So we want to use sine or the reciprocal of sine. Both of those work. Because sine of 33 degrees is equal to the opposite over the hypotenuse. You could have also said that cosecant of 33 is equal to the hypotenuse over 220. So both of these work, doesn't matter. But you have to choose yourself, I'm not going to tell you. So see what's missing and see what you have and set up your trig function. Okay. That makes sense? So I'm going to take the reciprocal of both sides or cross multiply however you want to think about it. I don't care. You're going to get 1 over sine Right, if I flip both sides over, get to here, that looks like the weirdest H ever. Okay. Multiply both sides by 220. Actually, that's not degrees, it's just 220 feet. My mistake. So punch that into your machine and you'll have the hypotenuse, which is the guy wire, right? 220 divided by sine. First of all, am I in degrees? Yes. So it looks like about 403 feet, 0.94. So this is 400. Ouch, whatever here. Hypotenuse is 403.94 feet. That's what they want to know. Any questions on the setup or any part? Okay. It looks like the answer is A. $13. We did something similar like this one in the homework. Find the exact value of the trig function. So basically, they give us tangent. They tell us the quadrant. Find cosine. So build a triangle and put the positive and negative signs in the correct spots. In quadrant 2, x is negative, right? Y is positive. Tangent is equal to y over x. So put the negative in the right spots. There's 13. All right, let me switch back. So I shortened it up. So tangent is equal to negative 2/5. Theta is in quadrant 2. Find cosine. That's basically what they want us to do. That's it. So triangle. Opposite over adjacent is tangent, right? Y over x. So the x must have the negative. Because we are in quadrant 2. Because when they write it this way, they're not telling you where the negative goes, right? It's just in front. Technically, you could go up or on the bottom. That is equal. Either one is equal to this. But quadrant 2 tells us where. All right, so find the C. Hypotenuse is always positive, so don't even worry about that. 29. So cosine theta is equal to adjacent over hypotenuse. Wrote that weird. Okay. Rationalize it. You got to multiply by root 29. It'll be negative 5 root 29 over 29. Any questions on the setup or the final answer? All right. $16. Find the amplitude. All right, we take the positive value, whatever, the absolute value of whatever number is in front of the function. That's amplitude. They didn't ask, but if they asked for a period, what would it be? Right, we take this number. Divide by this. Actually, that's wrong. It's 2 pi divided by that number. Anyway, they just asked for this. The rest are graphing questions. So I'll leave those to you, but that's all for the review. Do you have any questions on any of these problems? All right, I'll save the last bit of the time for homework questions. Oh, the period is always going to be 2 pi, Gabby, divided by whatever number is next to the x. So 2 pi over 4. That reduces to pi over 2. So the period is this guy. All right, please work on your homework and let me know if there's some stuff you're stuck on. So 17 would be, yes, 17 would be B. Mhm.